This is a video for AQA Further Pure Mathematics, Numerical Methods section 1.2, where we're considering whether numerical integration using the mid-ordinate rule gives an over or under estimation. In a previous video then we developed the mid-ordinate rule, which is given by this formula here. The idea is that we're looking at the midpoints of the intervals and calculating the y values at those midpoints, hence the mid-ordinate. The width of the rectangles that we're using is given by b minus a, where b minus a is the total width of the interval that we're considering, divided by n, the number of strips. In the previous video also we saw that for this particular integral, which is the integral of 1 over x between 1 and 2, that the mid-ordinate rule produced an underestimate. And that's because the pieces that are missing from the rectangles here, or below the curve, are larger than the extra pieces that are in the rectangles above the curve. So in general then, if the curves are this sort here, which are referred to as being concave upwards, then that is always going to be the case that the area which is missed out is larger than the extra piece which is included in a rectangle. If, on the other hand, the curves are concave downwards, as in the second diagram, the area which is missed here from the integral is smaller than the extra piece which is included in the rectangle, which is above the curve, and therefore that would be an overestimate. So now I'm going to consider one further example just to illustrate this idea a little bit further. So here we're asked to use the mid-ordinate rule with 3 strips to find an approximation to the integral from 2 to 8 of log x to the power 4 dx. And then once we've done that, to decide whether this would be an overestimate or an underestimate of the exact value. Well, the first thing to do is to decide what the interval that we're looking at goes from 2 up until 8, and if we're splitting it into 3 parts, then we can see that the width of each will be 8 minus 2 divided by 3, which is equal to 2. And therefore the x values for the mid-ordinates are going to be at 3, 5 and 7. The integral of log x to the power 4 can actually be written as 4 multiplied by the integral of log x dx. That's because 4 log x is the same as log x to the power 4. So we can evaluate that between 2 and 4. Therefore, using the mid-ordinate rule, we can say that's approximately equal to 4 times, and then the mid-ordinate rule says that it's h, which we've decided is 2, and then multiplied by the sum of the ordinates, which is going to be log 3 plus log 5 plus log 7. And if you evaluate that, you find that the answer is 37.23. To consider whether this is an over or under estimate, then a sketch graph will help. We know that log x goes through 1 on the x-axis and has a shape something like this, and so log x to the power 4 is going to be very similar. It's just stretched by a factor of 4. So critically, we can see here that this is a downward facing concave curve, and therefore each of the rectangles that we draw, the extra piece which is above the curve is going to be larger than the piece which is missing from the integral, and therefore this must be an overestimate. So let's just look at that again then. The mid-ordinate rule is given by this formula, where the width of the intervals, or the width of the rectangles, is given by b minus a over n, depending on the number of rectangles that you're using. We calculated therefore that the mid-ordinate rule value that we get for the integral was 37.23. A sketch graph shows that it is concave downwards, so it looks like this, and therefore we can say that the portion of the rectangles above the curve are larger than the missing pieces which are below. So this portion here is larger than this piece here, and therefore this must be an overestimate of the exact value. Well, that concludes this video on the mid-ordinate rule, and in the next one we'll be looking at Simpson's rule for numerical integration.